Okay, I'm going to go through a few questions and make sure we understand them. Your questions may not be in order, so just make sure you follow along. Which is not an effect of the graph from the parent function f of x equals x when f of x is should be replaced by f of x plus 2. So this piece on the outside, when I see f of x plus 2 on the outside, you want to recognize that this is going to move my graph up or down. So since it's plus 2, I need to recognize it's moving up 2. So the graph shifts up 2 units up. That is correct. I'm looking for something that's not part of this. The graph shifts 2 units to the left. Well, when it does shift up, it is shifting to the left. If you need to visually see that, you can graph this in the calculator. The x-intercept moves to 2, 0, or the y-intercept moves to 0, 2. So we know that the y-intercept is going to move to 0, 2 because it's moving up. The x-intercept, however, will not be at 2, 0. The x-intercept is moving to the left. When I move up my graph, I'm moving to the left. And you can check that in the calculator by graphing the parent function f of x equals x. And when you graph the transformation f of x, g of x equals f of x plus 3, you're going to see, plus 3 or plus 2? Plus 2. So plus 2 will move my graph up, but not only is it moving it up, it's moving it to the left as well. So the x-intercept is at negative 2, 0. Next question. The linear parent function is graphed on the grid. The question is asking which graph best represents h of x equals negative f of x plus 5. So you want to recognize what are the transformations given the new function. So the negative on the outside is a reflection, and the plus 5 on the outside is going up 5. So reflection means it changes my slope to be negative. So if it changes my slope to be negative, I'm going to be looking for a negative slope. That's here, and it moved my graph up 5. If I take a look at the other graphs, this moved my graph down. That's not correct because it says plus 5 on the outside. This did not flip my graph to become negative. And on the last graph, it moved my graph down and it did not flip it to show reflection. So the correct graph would be this one. Next question. Write an equation for g of x, a translation of f of x 4 units to the right and 3 units down. So if you go back to your transformation notes, to the right and down, when I'm moving to the right and left, it's inside of the parentheses. So when I move to the right, I'm going to have a minus sign. When I move up or down, it's on the outside and it's addition or subtraction. So when I look back, if I needed to write a transformation 4 units to the right, I need to recognize this goes inside my parentheses, and it's the opposite if I'm moving to the right. So this should be x minus 4. And if I'm moving down 3 units, that's a minus 3 on the outside. So you're looking for the function to match that description. Next question. Mary graphed f of x equals x, that's the parent function, and g of x equals f of x plus 4 in the same grid. Which statement describes how the graphs of f and g are related? So if I look at this plus 4 on the outside, it means I'm moving my graph up 4. So the graph of g is less steep than the graph of g. The graph of f is less steep than the graph of g. Well, here there's nothing going on with my slope. So no, that's not correct. The graph of f is shifted down 4 units to create the graph of g. No, it's a plus 4, so I'm moving up 4. The graph of f is shifted 4 units up to create the graph of g. Correct. The graph of f is steeper than, no. We are not changing the slope, so it's not steeper. On the next question, what is the effect of the graph of the parent function of f of x when g of x equals 9 f of x? So this is multiplication. I'm no longer moving my graph up or down. I'm changing the steepness of my slope. So I want to be careful and make sure I understand that. If you're a little bit confused, you can take your graphing calculator. Here's f of x equals x, and you can show that multiplication. And when you see that, you're going to notice that the blue line, it moves from your red line to the blue line. So my graph is becoming more vertical. When your graph is becoming more vertical, that line becomes steeper. It's harder to walk up a steep hill. So notice it that it's very steep going up. So when I look to answer my question, the graph becomes steeper and the intercepts stay the same. If I go back and look at my Desmos graph, my x and y intercepts stay the same. I didn't add or subtract anything to my graph. I didn't change the x values on the inside. So that is true. If you go on to read the rest, the graph becomes steeper and the y-intercept changed. No, the y-intercept never changed. The graph shifts up 9 units, not up 9 units, because it's not addition on the outside. The graph shifts to the left 9 units. That's not correct. That would be on the inside of the parentheses. So the graph becomes steeper would be the correct answer. Which is not an effect on the graph of the parent function f of x when transformed to g of x equals f of x minus 8. So we're trying to find something that's not an effect. So if when I look at f of x minus 8, I need to recognize it's on the outside, so it's moving my graph down. So the graph shifts down 8 units. Correct. The x-intercept becomes 8, 0. When my graph moves down, my x-intercept is also moving to the right. So this is actually correct. So the graph becomes less steep. My slope isn't changing. I'm not multiplying anything to my graph, so this is actually the correct answer. The y-intercept moves to 0, negative 8. That's correct because this moves down to negative 8. Again, you could graph this in the calculator and take a look at what happens to that function. So if I put minus 8 on the outside, you're going to notice your graph moves down 8 units and your x-intercept is also at positive 8. Next question. How does the graph of the line y equals 1/3 x differ from the graph of the line y equals x? So y equals 1/3 x is less steep than y equals x. So you want to recognize that this is multiplication with x. So anytime it's multiplication, it is changing my slope. So if I have a slope of 1/3, it's up 1 right 3, up 1 right 3. So you're going to notice that your line does become less steep than the parent function. So the answer choice would be less steep. When you read the other answer choices, the y-intercept of y equals 1/3 x is 1/3 unit higher than the y-intercept of y equals x. No, the y-intercept would change if it's addition or subtraction on the outside. Y equals 1/3 x is more steep. Well, no, if we graph this and take a look, 1/3 is less steep than your slope of 1. So that's not correct. The x-intercept of y equals 1/3 is 1/3 unit to the right of the x-intercept. That's not correct. Again, 1/3 times x is going to make your graph less steep. And you can graph this to check. Next question. Describe the transformation that is used to form the graph of the linear parent function f of x to become the graph of a g of x equals f of 0.3x. So this is where you want to recognize your notation. If it's on the inside, it's a horizontal stretch or compression. So you can automatically eliminate vertical stretch compression because that's on the outside. when it's on the inside, you want to recognize that when this value is in between 0 and 1, we will be stretching the graph. So this is going to be a horizontal stretch. And again, it's going to take you memorizing your transformation rules. If you go back to our notes, here, multiplication inside the parentheses is a horizontal stretch or compression. So when it's in between 0 and 1, we call it a horizontal stretch. Next question. Linear function f of x is graphed on a coordinate plane. The graph of a new line is formed by changing the slope of the original line to 3/4 and the y-intercept to 5. Which statement about the y-intercept about the relationship between these two graphs is true? So if I'm changing the slope to 3/4 and the y-intercept to 5, I'm moving up 5, and I want to recognize if my slope becomes 3/4, this is becoming a less steep line. So the graph of the new line is less steep than the graph of the original line, and the y-intercept has been translated down. My y-intercept has been translated up because it's a positive 5. So the graph of the new line is less steep than the graph of the original line, and the y-intercept has been translated up. This is the correct answer. If we go on to read the next few statements, the graph of the new line is steeper. That piece is not correct because 3/4 would make this slope less steep. The graph of the new line is steeper. Again, that's not correct. And if you need a visual, graph this for yourself. Graph the parent function and graph the new line. So if I graph the parent function, y equals f of x, and you can graph the second function exactly how they told you. G of x equals, so g of x equals 3/4 x plus 5, because my y-intercept has changed to 5. So you're going to notice that this graph moved up 5, and my slope has also changed. So it's moving up, and my slope is changing to become less steep. Next one, determine the effects on the graph of the linear parent function f of x equals x to become the graph of g of x equals f of 8 times x. It's on the inside of the parentheses, so I want to recognize that that's a horizontal stretch or compression. So let's make sure we understand. What's on the inside in its multiplication, we're not moving this graph up or down, left or right. This is going to be affecting my slope. So the y-intercept of g of x moved up 8 units. That's not correct. The graph of g of x of f of x became less steep to become g of x. So you want to recognize that 8 is going to be multiplied with your slope. So think about what that's going to do. So before we answer this, I'm going to read on. The y-intercept of f of x moved down 8 units. That's not correct. The graph of f of x became steeper. So you want to recognize when you have 8 multiplied with x, what is that going to look like on your graph? So let's go ahead and graph that. F of 8x. So looking at that blue line, it's becoming more vertical. So the more vertical that line becomes, the steeper it is. So this is a steeper line, not a less steep line. So make sure you understand the difference with steep and less steep. This question says the graph of linear function f, red line, and g, blue line, are shown on the grid. Our question is below. Which function is best represented by the graph of g? So when I look at this graph, I want to recognize it didn't move up or down, left or right. So I should automatically eliminate the answer choices that show that I moved up or down. And now I'm just going to focus on the multiplication. So when I look at this multiplication, I want to recognize, well, if it's 1/4, my graph becomes less steep. If it's multiplied by 4, my graph should become steeper. So when I look at this graph, it's up 1, right 1, 2, 3, 4. So up 1, right 4 changes my slope to 1/4. So I want to recognize that the correct answer would be 1/4 times f of x. Next question. The graph of the linear parent function f of x is reflected over the y-axis. So which of the following function represents the new function? So you want to be careful. When we talk about reflection, we're talking about a negative. So a negative value with your x. Reflection over the y-axis. The last question. The graph of y equals 2x minus 3 is shown. What is the equation of this after it's been translated 3 units to the right? So this was a challenge question in your notes. So 3 units to the right. I want to recognize when I move right and left, it's inside the parentheses. If I move right, it's the opposite sign. So I should see x minus 3 inside the parentheses. Nothing else changes in my equation. I still keep my y equals, I still keep my slope of 2, and I still keep the minus 3 on the outside. So this is the type of equation you'd be looking for.